Hi, this is the Trig Identities homework. I will do the odds to give you some basis to go from. Problem number 1, I see a 1 minus cosine squared over sine squared. Okay, there's two ways to go about doing this, but anytime you see a 1 and a cosine squared together, it probably involves that Pythagorean identity that I said is really important on the regions. So I will write that out for you again. This is the identity you need to know. Oops. And if you subtract over cosine squared theta, you're going to get sine squared theta equals 1 minus cosine squared theta. So there it is. 1 minus cosine squared theta can be substituted with a sine squared theta. Okay, so that means sine squared theta over sine squared theta that was already there. And these two cancel out and make 1. Now I will just say this one time. If it is a multiple choice expression problem, you can check your answer by storing. And you can even use a theta if you want. The theta symbol on the 84 is alpha 3, that's theta. And if you really want to, you can replace that with an x. Most of you guys would probably prefer that. So I'm just going to pick a 5. I'm going to store it. I'm going to use an x. If I want to type 1 minus cosine squared theta, which I'm going to use x, it would be 1 minus cosine. And I know this is bad, but you want to put a square there. But notice they already gave you the space to put the angle. So on a calculator, not the way you write it, but on the calculator, you will actually, in fact, do 1 minus cosine theta and then put the square power like that. So that's just the way the calculator is, but the normal way to write it is what's written on your paper. Over sine squared theta. Again, they already prompt you to do the angle, and then you do the squared like that. And that means the same thing. That's what's written. And it does, in fact, equal 1, and that's choice 1. And this can be done in all the multiple choice questions. Okay, example or problem 3 of your homework. This one, you see a cosine squared, and then you see a sine squared, but what might be throwing you off is that there are 4 thetas. Since both 4 thetas are on both angles, you can just treat that as a big fat angle A. That's a big fat angle A. So cosine squared A plus sine squared A is equal to our Pythagorean identity 1 again. So they just wrote that to try to confuse you to see if you thought that there was more involved. But anytime you see cosine squared plus sine squared, if they're the same angle, it actually equals 1. Okay, so number 5. How would we do that? Well, sine squared, well, I'm going to leave that alone for a second. And cosine is rock bottom. And cosine theta over here is rock bottom. So, okay, it looks like we have nothing we can replace with. So now we have to talk about adding fractions. If I'm adding fractions, I need an LCD. Since this is cosine on the left, and this is 1 on the right, I got to get them both to be the same. Well, I can multiply this by cosine to change that to the same denominator. But remember, whatever you do to the denominator, you have to do to the numerator to keep the fractions equivalent. So now that I make that change, I have sine squared theta over cosine theta plus cosine squared theta over cosine theta. The reason why we needed to have common denominators is when you add fractions, you keep the common denominator on the bottom. And then you just simply add these two. And sine squared theta plus cosine squared theta is, again, our little famous Pythagorean identity, and that makes a 1. So we look at our choices, it's not there because 1 over cosine actually is, in fact, something else. 1 over cosine is cosine flipped, and cosine flipped is secant theta. And that would be choice 2. Now, again, if you wanted to store and check your answer, don't forget on the 84 calculator, you would in fact had to have typed 1 over cosine theta to represent secant theta if you wanted to check that answer. Okay, number 7. The expression cosecant theta times 2 sine theta is equivalent to what? Well, cosecant theta can be written as 1 over sine theta. And sine of 2 theta, well, that's our double angle. So this means to go to your formula card. So if you look at your formula card, there is only one formula for that. It's 2 sine, I know it says A, but remember that's a generic angle. Our angle in our problem is theta, so we can replace that with theta instead. Because you're multiplying fractions, we can reduce before we multiply. Well, this sign and that sign can reduce out, and that's it. So you have a 2 left and a cosine theta left, which is choice 3. Okay, 9. Simplify again. All right, sine theta is rock bottom. We are multiplying, and then secant theta. Well, secant theta is cosine flipped. So 1 over cosine. I am multiplying 2 fractions. Nothing can reduce out, so I multiply side to side. Sine theta times 1 is sine theta, and 1 times cosine theta is cosine theta. Sine theta over cosine theta is kind of like O over A, and that's tangent for OA. So that really is tangent theta, and that would be your single function. (11). This is just like problem 9, except there's 3 instead of 2. It's the same process. Secant theta is cosine flipped, so that's 1 over cosine. Cotangent is tangent flipped, but that's not going to help us. Remember, tangent is O over A. That means cotangent will be A over O, and A goes with cosine, and O goes with sine. That's how you can help remember that one. And sine theta is just rock bottom. Nothing we can do with sine theta. So before we multiply, we can reduce. This denominator cosine reduces with that numerator cosine. This denominator sine reduces with that numerator sine. And everything cancels out to 1. So that is equal to 1. (13). Cotangent theta divided by cosecant theta. Well, cotangent theta is, again, it's our OA for tangent, but cotangent is A over O. So it's going to be cosine theta over sine theta. Divide. And then cosecant is sine flipped. So that's going to be 1 over sine theta. So since you have a fraction being divided by another fraction, you change that to multiply. And division is really multiplying by the reciprocal. So you reciprocate. And that just means flip. So we have cosine theta over sine theta. Change times and reciprocate. So now it's really a multiplying fractions problem again. The signs cancel out, and you're left with cosine theta. (15). Simplify tangent squared theta over sine squared theta. All right, well, going back, like I said, tangent theta is equal to sine theta over cosine theta. And if you want to square the tan, you square the fraction. So that's what tangent squared is. So that's going to be sine squared theta over cosine squared theta for the tangent squared theta. Fraction bar. Sine squared theta, we could try to use the Pythagorean identity, but we normally don't try to expand out. We try to keep it together. So sine squared theta, we're going to leave alone. So again, we have the keep, change to multiply, and reciprocate. All right. Sine squared theta over cosine squared theta. Change and reciprocate. Now really remember, that's really over 1. That helps you see that better. Okay, so the sine squared in the numerator and the sine squared in the denominator are both like and they cross each other off. So you're left with 1 over cosine squared theta. And that's cosine flipped, which is secant. And because it's squared, it's a squared function as well. So secant squared theta. All right, 17. 1 minus cosine squared. All right, if you ever see a 1 in a cosine squared, a 1 in a sine squared, or a sine squared and a cosine squared, again, you know it probably is using that important identity. And I can get it to look the same if I bring the cosine squared over. So 1 minus cosine squared is right here. I can replace that with a sine squared. So that numerator is really sine squared theta over sine theta. All right, 2 sines on the top and 1 on the bottom. This sine reduces into that sine squared, and you have a sine left. So that really is reduced to sine theta. Okay, number 19. Okay, so number 19. This one looks really hard, but we'll start slow here. Cosecant theta, I can replace that with a 1 over sine theta. And so if I leave the other fraction alone a second, I'm subtracting fractions, and if I'm subtracting fractions, I need an LCD. So I really don't want to make any more changes besides that one, because I now have a common denominator. Okay, so that means I can combine them into a single fraction by keeping the denominator and just subtracting the 2 numerators, which are just going to be written as 1 minus cosine squared. Well, 1 minus cosine squared we actually did in the previous problem, number 17. That is actually sine squared by the same reasoning I already used. And sine squared can be reduced with sine one time, and you have a sine theta left. All right, one last odd problem, 21. Okay, so we have 2 operations going on. We have sine theta times tangent theta, then we have an addition. All right, so let's replace whatever I can. Sine theta is rock bottom. Tangent theta is O over A, so that's going to be sine theta over cosine theta. And then cosine theta is also rock bottom. You're going to perform order of operations in the order that you would normally do. We would normally multiply before we add. So we're going to go ahead and do these 2 first. Nothing cancels out, so we're going to multiply side by side. Sine times sine is sine squared, just like x times x is x squared. 1 times cosine in the denominator is just cosine. Then we still have this plus cosine. And then we have a problem because we need to have an LCD to add fractions together. So to create an LCD, I need them both to be the same. And 1 is actually easy to change. I can multiply a cosine theta to 1 to make it look like cosine theta, as long as I do the same to the numerator. And then I'll have a common denominator. So sine squared theta over cosine theta plus, well, these two make cosine squared theta over cosine. I have a common denominator now. So now I can simply keep the denominator cosine. And I can add terms together. These don't look like they're alike, but cosine squared plus sine squared is that identity. It equals 1. And 1 over cosine is secant flipped, so it's secant theta.